You are welcome to this lesson. The topic is nominal interest rates and compound interest. By the end of this lesson, you should be able to explain what a nominal annual interest rate means when interest is compounded more than once per year. Identify the compounding frequency, M. Compute accumulated amounts using the compound interest model with M being greater than 1, and solve for the unknown, either A being the accumulated value, P the principal, or T time in compound interest problems with frequent compounding. A nominal interest rate R is an annual rate that is converted into periodic rates when interest is compounded more than once in a year. Compound interest model The compound interest model is given as A equals P times 1 plus R over M, all raised to the power M times T, where your A is the accumulated amount, P is the principal invested, R is the interest rate, M is the number of times in a year interest is compounded, and T is time. So some examples of compounding frequencies are semi-annual, where M is equal to 2, which means that interest is compounded 2 times in a year. In the first 6 months, we compound interest once, and in the final 6 months, we compound interest again. So interest is compounded 2 times in a year. There is also quarterly compounding, where interest is compounded 4 times in a year, and there are 4 quarters within a year. So after every quarter, interest is compounded. We also have monthly compounding where M is equal to 12, indicating that interest is compounded 12 times in a year. Then finally, there is daily compounding. Now, the periodic rate and number of periods. So we have M being the number of periods in the year that interest is compounded. Therefore, the interest rate per period. In the case of quarterly, the interest rate per quarter is the interest rate R given for the whole year divided by M, which is the number of periods in the year. So the total number of periods then is equal to the number of periods within each year times the number of year under consideration. Let's take an example. Given that the interest for a particular year is given as R being equal to 10%, and compound interest is compounded 4 times in a year quarterly, then the periodic rate is equal to 0.1, which is 10% over 4, and that gives 0.025. Let's consider that T is equal to 5. So this investment or this transaction is spanned over 5 years. Then the total number of periods is equal to M times T, which is M is here 4. So 4 times T give 5, which is giving us as 20. So the total number of periods under consideration is 20. Let's look at an example. A student invests 5,000 at a nominal rate of 8% per annum, compounded quarterly for 3 years. Find the accumulated value. The formula for find the accumulated value is given as A equals P times 1 plus R over M to the power M times T. Now let's find out the for each variable, let's find out what information we have from the question. The student invests 5,000, so P is equal to 5,000. R is equal to 8% per annum. T is 3. It's compounded quarterly, so M is equal to 4. Now, given that we have these values, we can attempt to find A. So A is equal to P, which is 5,000, times 1 plus R, 0.08 over M, 4, raised to the power M, 4 times T is 3. So we simplify to get 5,000 times 1 plus 0.08 divided by 4 gives me 1.02. So I have here 1.02 raised to the power 12. So this proceeds to give us a final answer of 6,341.21, leaving it in two decimal places. Therefore, the accumulated amount after 3 years of investing 5,000 at 8% per annum compounded quarterly is 6,341.21. Question 2. 10,000 is deposited at a nominal rate of 12% per annum, compounded monthly for 2 years. Find the accumulated amount. For the accumulated amount formula is given as A is equal to P times 1 plus R over M raised to the power M times T. Therefore, first of all, we have P is equal to 10,000, the principal. T is 2 years. M is 12 because we are compounding monthly. And R is 12%, which is the same as 0.12. Therefore, A is equal to 10,000 times 1 plus R, 0.12 over 12, raised to the power M times T, so 12 times 2. This goes on to become 10,000 times 1.01 raised to the power 24. So finally, we have 12,697.35 as our final answer for the accumulated value after 2 years of investing 10,000 at 12% per annum compounded monthly. Question 3. 8,000 cedis is invested at a nominal rate of 10,000 per annum for 2 years. Find A if interest is compounded semi-annually, and find A if interest is compounded quarterly. Which option gives a larger accumulated amount? So let's find A. First of all, let's write our accumulated value formula. We have A equals P times 1 plus R over M to the power MT. So for question 1, we want to find A when it's compounded semi-annually. We have, first of all, let's write out our variables. We have P being equal to 8,000. R is 10%, equal to 0.1. T is 2 years. So for semi-annual, M is equal to 2. Therefore, we have A equals P times 1 plus R, 0.1 over 2 to the power M, 2 times T, which is also 2. And this gives us P is then 8,000. So let me write the 8,000 here. Times 1 plus 0.1 over 2 raised to the power 4. Now this is going to give 8,000 times 1.05 to the power 4. And finally, we have 9,724.05. Let's look at the case of the quarterly compounding. Where M is equal to 4. We have A equals 8,000 times 1 plus 0.1 over 2 to the power 4 times 2. And this gives 8,000 times 1.05 to the power 8. Oh, this is supposed to be MS 4. So I'm going to change this. Okay. So this is 0.1 divided by 4. This gives me 1.025 to the power 8. Then finally, I have 9,747.22. So the next third question is saying, which option gives a larger accumulated amount? The option of quarterly compounding is greater than the option of semi-annual compounding. So this is greater than this. This one is bigger than this one. Therefore, the quarterly compounding gives you a bigger accumulated amount. So question 4. An amount grows to 15,000 cedis in 4 years at a nominal rate of 9% per annum, compounded semi-annually. Find the original principal, P. Once again, we write the formula for finding the accumulated amount, which is A equals P times 1 plus R over M to the power MT. In this case, we want to find the original principal, which is P, because we are given A. So the amount, an amount grows to 15,000 in 4 years. So in 4 years, the amount will be 15,000. If you draw a timeline like this, we are here today, time 0. This is time 4. Now, there's an amount here, P, we don't know. It will grow to 15,000 in 4 years. So the 15,000 we have is our A. And that's equal to P, which we don't know, times 1 plus R is 9%, so 0.09 over M. This is compounded semi-annually, so M is equal to 2 to the power 2 times T is 4. So 4. So we can simplify this to get 15,000 equals P times 1.045 to the power 8. Therefore, P is going to be equal to 15,000 divided by 1.045 to the power 8. And we have P being equal to 10,547.78. Therefore, if you invest 10,547.78 at time 0 here in 4 years' time, you should get 15,000 at 9% per annum, compounded semi-annually over a period of 4 years. So what we wanted to find was our P, and we have done just that. Finally, 6,000 grows to 9,000 at a nominal rate of 10% per annum, compounded monthly. How long did it take? We have A equals P times 1 plus R over M to the power M times T. You should have gotten used to the formula by now. Now we say that we are here at time 0 and we are here at time T. That's how long. We want to find how long in years did it take. So we don't know T. What we want is T. So we are here at 0. We put in 6,000. It grows to 9,000 at time T. Therefore, A is our future value, 9,000, equals to the principal of 6,000 times 1 plus R is 10%, 0.1 over M is compounded monthly, so M is 12 to the power 12 times T. So we can divide both sides by 6,000 to get to have 9,000 divided by 6,000 equals 1.00833 to the power 12T. So this gives us 1.5 equals 1.00833 to the power 12T. We have to take log of both sides to get our T. So we have ln 1.5 equals 12T times ln 1.00833. Now, let's take the ln. This is a constant, so we'll take it to the left-hand side. So we're going to divide here by ln 1.00833 and divide here also by ln 1.00833. So finally, I'm getting ln 1.5 all over ln 1.00833 is equal to 12t, because this cancels out this. Therefore, now I have t being equal to ln 1.5 all over 12 times ln 1.00833. And that finally I'm getting t equals 4.07. So it will take an approximate time of 4.07 years to put in 6,000 and make 9,000 at 10% and being compounded monthly. So we have our t equals 4.07. Thank you for being in this lesson. I'll see you in the next lesson.